Hello everyone, today we are going to discuss about the brief introduction of the structural analysis. So as you can see here, we have a simple beam structures and subjected to the three different amount of the point loads, and you can see the boundary conditions here, the roller left hand side and the right here. This is the pin, so that we call the pin simply supported boundary conditions. And of course, based on these kind of given load, we can calculate the reaction force or the moment. And based on these applied load and the reactions, we can think further about the internal structure behaviors. So the main objective of these short video clip is to introduce you the structural types, load, and the design considerations. So let's get it started. So before that, I would like to introduce the reading materials. And there are several books available, but in this module we'd like to adopt the basic shape theory and the ultimate limit state analysis and design of the plated structures. And the right hand side you can see that the mechanics of the material, or we call the solid mechanics, and the structural analysis. Those two books are authored by the Hibla, which is most famous book in nowadays. And let's have a brief discussion of what is the structure and how to analyze it. So in the case of structures, that could be referred to a system of connected parts used to support the applied loads. So these structures could be split into three. And firstly, this is the offshore structures, including the marine, ocean, subsea, naval architect, and the shipping, something like that, ships and offshore structures. At the same time, we can see the nearshore structures, for example, the coastal structures, and also we can see the onshore structures like the civil, bridge, highway, buildings, something like that. So this is the overall picture for the structure design, but basically we are currently here structural analysis, which means that you can see the overall the gear system, all those components, structural mechanics and analysis and the design are actually one set. So previously we learned about the structural mechanics, which is including the statics and the solid mechanics. And now we are dealing with the theory of structures, or we call the structural analysis. So based on those two fundamental elements here, the structural mechanics and the skills how to do the structural analysis, based on these we can focus on the structural design. So what is the structural analysis and how to do that? That is the determination of the effects of the load on physical structures and their components. So let's more focused on the structural analysis, how to do that. So basically there are three types of the method. So this is the analytical method, which will give us the absolute solutions, but at the same time we can focus on the numerical method. Nowadays we have a number of numerical method simulation code commercialized softwares, such as the finite element method, or the open source OpenFOAM, or the CFD, something like that. And this is the experimental method, or we can consider as the testings. So basically the testing will give us the very best outcomes, but we can also think about the cost and the time required. And in the case of analytical method, which will give us the absolute solution, but if the structural shape is much more complex, then it might be difficult for us to set the governing equations, to set the boundary conditions. That is reason why nowadays most of the engineers, they do prefer to use the numerical method. So it's like these, the finite element examples, and they have applied the load, and you can see the von Mises stress or the displacement, something like that. But don't forget that this kind of the finite element method or the numerical method, that should be at least a few cases should be validated with the analytical and the experimental studies. So let's say the structural element types. Basically we have the 1D, 2D and 3D element types, and actually we have the column members, the 1D slender member subjected to the axial compression, the 1D element subjected to the tension, and 1D element resisting the bending moment, that is the beam. And in the case of a finite element, we can see here, this is the application, this is the crane structures. You can see the members here, 1D slender members. And in the finite element, we can consider this is the length element, or the 1D element, or the line element. So the shape and the node will be like that. In the case of 2D, we have the shell element, or we call the thin walled structures. So 2D applications are here. You can see shell element, and we consider as the area in finite element. So you can see here, this is triangular, but also we can consider rectangular or other shapes as well. And 3D applications, this is called as solid. And this is the much more complicated than the 1D and 2D element. You can see the shape. Of course, it might take additional time, effort to do the structural modeling in the finite element. So this is the volume element. You can see some of the examples like here or like that. And number of element and the element type we can discuss further in the finite element method sections. So types of the boundary condition, this is truly important for us, and generally we can see that the free or the roller, pin or fixed internal hinge. Of course, we have furthermore cases, but those 5 are considered as the general boundary conditions. So in actual, you can see that this is the cantilever conditions, but here they are talking about right hand side here. So basically this is the free conditions, and how to sketch it, think about it. Pretty soon we will we will sketch it together. And in the case of roller, generally we can see that this is the roller system, like here. Sometimes we put it like that, or represented by this shape. And in the case of pin, most common cases, or we call the hinge conditions. And this is the fixed condition, left hand side, right? And the internal hinge like that. So how to sketch it? Look at that free condition, we don't need to do anything, but in the case of roller, you can see here, this is the roller system, which means that we can move to the left, to the right. And the pin conditions, as you can see here, we cannot move left and right and up and down, right? But the moment is free. In the case of fixed conditions, we do not allow to move left, right, and up. At the same time, moment is also fixed. So internal hinge can be presented like that, right? So previously we discussed about the applied load and the boundary condition. Of course, we should know how to establish the free body diagram and types of the structural system. And this is the truss members. This looks like the oil and gas production system. We call the fixed jacket platforms, and based on constructed by the truss elements, and the cable and the arches. This is the bridge, and the frame structures like that, and the surface structures as well. So at the same time, we can see the types of the load. Of course, we have the onshore and the coastal nearshore structures, as well as the offshore, ocean, marine. And types of the load could be split into 2, dead load and the live load. So in the case of dead load, we have the self-weight from the structural element, and the live load case in the civil, and we have the building, highway, railroad, impact, and the wind, snow, and earthquake, hydrostatic, and etc. And in the case of offshore structures, we have the cargo load, and those 3 are important: the wave and the current load, and the wind load. Those 3 are main the load component to the ships and offshore structures. And sometimes for the fixed platforms, we need to consider soil and the earthquake and the other types of the natural or the accidental load as well. So structural design concept, let's briefly discuss about it. Design concept. So previously we focused on the working stress design concept. We call it WSD, or the allowable stress design concept. And this concept focused on the computer elastic stress in the material must not exceed the allowable stress, which means that if you think about the structural coupon test, the material test, the tensile test, then we can clearly define that the elastic limit and the elastic limit below that, we can see that we don't allow the plastic deformation. So based on that, the yield strength we can multiply, for example, the 50% or the 70%, that could be considered as the working stress design. Is up to the designers. At the same time, we have the recently we proposed the limit state design, or the LLFD limit state design, that includes the ultimate limit state and the accidental limit and the fatigue limit and serviceability limit. So for example, in this case, this is the previously the working stress design concept is the single factor safety based design concept, and this LSD is combination of the load and provide a maximum yet realistic loading on the structures. So this could be considered as the robust design and the recent trend. So HSE, we should clearly understand about this, the concept, the health, safety, and the environment, of course, and the safety is the priority for us, and health is also very important, and the environment, we want to protect it. So in the marine industry, we have the IACS, International Association of the Classification Societies, and IMO, pretty much famous organization, International Maritime Organization, and International Organization for the Standardizations. So we have the IACS, the Harmonized Common Structural Rule and Goal-Based Standard from the IMO and ISO rules. So what they are doing is they want to investigate and further develop the advanced technologies, so that they are focusing on the first principle based and direct method, and the limit state based method, and the risk based method. So if we see further, and onshore, nearshore, and the offshore structure design code, there are so many different types of the design code available nowadays, but this is a brief summary. We have the American Association of the State Highway and Transportation Officials, and AISC, ARAA, and we have the ASCE. This might be familiar with you guys from the Civil Engineering, American Society of the Civil Engineers, and British Standard, quite famous, and Eurocode, and etc. And in the case of marine industry, we have the IMO and ISO, and the recently International Gas Carrier Code for the LNG, or the liquefied hydrogen ships. IGC code is highlighted, and we have the IACS, International Association of the Classification Societies. Of course, petroleum industry, they adopt the API code, and ASME from the mechanical engineering, and etc. So this is the conclusion, and today we discussed about the types of the structural element, boundary conditions, structure system, and the load, and of course we discussed about the structural design concept, the overall concept discussed, and the design code. So basically in this module, we will discuss further about the theory of the structures. So thanks very much, and that's all for today. Bye bye.